Gotta love computers.
Yeah. Yeah, sorry about that. At my parents' house.
Oh, nice. Well, we'll try to make this as quick as possible.
It's all good. I regret to inform you that I have not looked at very
Well, this was the hardest review for me, so we'll see how it goes.
I'm really sorry, though.
No, you're good.
Okay, I'm working off two computers here, so.
Okay, no problem.
Okay, I'll do my best to help. Maybe I don't know.
Yeah, that's no problem at all. I don't mind. I just apologize in advance because I know that I didn't do so well. In fact, there's 2 sets of questions that I had to skip because I had no clue how to do them. So we'll see how this goes.
All right, hey, that's fine.
All right.
You're awesome for doing anything on it.
Well, I certainly did procrastinate it. My goodness.
All right.
All right. So I just went ahead and opened it up.
Okay. Yeah, that's what I'm going to do really fast. Right. Okay. So my brother actually, he's taking this class right now.
No.
He said that their teacher gave them a really handy, like a chart that helps them identify which hypothesis to use.
Oh, really?
And so he said he's gonna come down tomorrow. If I get it from him, I'll email it to you.
Yeah, I'd appreciate that because that's the biggest problem for me, and that was a huge chunk. In fact, I think this whole review was pretty much based off of how well do you know which test to use.
Really?
Yeah.
Okay, well, let's do it.
Okay, sounds
See if
good.
I can help. Okay, are you on 2?
Yeah, I am. Oh, I'll let you read that. It's a long one.
Okay. Yeah, sorry.
No, you're fine.
Reading through. Okay. All right. I read through this one earlier.
Okay. So again, I apologize if my answers are wrong, but I put E or let me see, ANOVA test.
You put in an ANOVA test?
Yeah.
Okay. All right. I was thinking paired sample, but like if your reasoning is better than mine, which probably isn't.
It probably is not better than yours. Let me see why I chose that. I think the only reason I chose it is because I was thinking that there were multiple groups, more than just 2, because you have the different educational levels within each group. But I can understand the. You said the paired sample t-test is the one you were thinking?
That's what I was thinking, but yeah, I don't know.
Yeah, that sounds good to me because it is United States and Korea, those 2.
Okay, well, if it's not that one, probably yours.
All right, sounds good.
Okay. Sorry, there's probably going to be a lot of pauses here.
Yeah, that's no problem at all.
So this is the one where they wanted to see age had a factor in people being fired. Is that
Yes. To see if the younger people were being treated as fairly as the older people over 30.
Okay. All right. Well. All right. Okay. What did you think on that one?
Okay, I put D, which was independent sample. Again,
that's actually what I was thinking.
Oh, okay. Cool.
But sorry if you were going to say more there.
No, it's we'll keep it there then. And this one I was really unsure about.
Okay.
But I put G.
G?
Yeah.
So test of one proportion?
Yes. Wait, let me see. Yep, test one proportion.
All right, well, I mean, that sounds good to me.
Okay. Give it a shot.
Yeah. Hey, thanks again, Thomas, for working so hard on this.
Oh, well, he didn't work too hard, but no problem. No problem at all. It was a very easy day. So, man, all of these have really long explanations for each question.
Yeah, they do. Okay. Give me 1 minute.
Okay.
Okay, on this one, I'm not sure. I mean, off the top of my head, I'd have to keep looking into it, but
this one I put, is it number 5? I put D.
D?
Which is also what I put for 2. I'm not sure why I did that one twice.
Yeah, that's okay. I think in the instructions it said it can happen twice.
Oh, okay. Independent samples. 25 students.
Yeah, I mean, looks good. It seems like they're focusing on 2 different groups.
Yeah.
Or just different groups. They don't have a correlation there. So.
Right. That's probably what I was thinking then.
Yeah, sounds good to me.
Okay.
Okay, so on this one, did you do like a paired sample confidence interval?
For this one, I chose confidence interval for 2 proportions.
Okay.
So they can see each other.
But actually, now that I think about it, this was an example that we used in an earlier one. I think it was for the paired sample. Way back when.
Okay.
So I think it would be...
Back in like... Sorry?
What were you saying there?
Oh, I was just going to ask like an example from our homeworks. Back in
Yeah,
the day?
yeah.
Okay.
So I think you're right with C. That's the one you said, right? Paired samples?
Yeah, but... Yeah, I don't know, you could be right too.
Right. We'll see.
Okay. Okay. Okay, well, this one to me seems like it would be D, like an independent sample.
That's what I was just thinking as well when I was reading over it.
Okay. Should we go with that one then?
One thing I don't understand, I guess, well enough is the difference between the intervals and the proportion tests.
Hmm. That is a very good question.
So it's possible that at least one of our independent sample answers that we did is a confidence interval for 2 proportions. I'm not sure, but that might be something to keep in mind when we check our answers and if we got any of them wrong.
Okay. Awesome.
Okay.
Great. So double stuffed Oreos.
Gotta love them.
Oh yeah, they're pretty good.
Agreed.
Okay, so just reading through that one, it sounds like one of the top ones probably one sample Z or one sample T confidence interval.
This is number 8. What was that?
Yeah, it's number 8. Yeah, I was saying that's what it seemed like to me. Maybe not.
You broke out there, though. But did you say it seems like D?
It's to me, it would seem like it would be either A or B.
Oh, B. Oh, okay. Yeah, I think I went along with B.
Okay. Awesome. So I have a hard time remembering the difference between a Z and a T, the Z test and the T test. But
What was that one more time?
I have a hard time remembering the difference between one sample Z and one sample T.
Oh, right. Yeah, I don't know if this is right, but as far as I know, one sample Z is when you know the standard deviation, but T is where you don't.
Oh, yeah, that does ring a bell. Okay. I think you're right. And on this one, you're right, we wouldn't.
And I think that's it for determining the tests right now.
Okay. Alrighty.
All right, so which of the following best defines the notion of the significance level of a hypothesis test? Number 9. I put B for this one.
The probability of the type 1 error.
Yeah.
Okay.
Does that sound right to you, or do you think you have a better idea?
Just 1 second. I didn't really absorb it that well the first time. Which one of the following best defines the notion of the significance level of a hypothesis test? I mean, it could be. Yeah, I think.
Okay.
Let's go with it. Okay, which one of the following best defines the notion of the p-value of a hypothesis test?
Number 10. Wait a second. Oh, right. When I was reading this out loud, Sasha said she thought it was C.
C, the probability of observing.
What was that?
Yeah, I was just reading it. Sorry. Yeah.
That was for the last one.
Okay. Alrighty, that sounds good.
All right. Okay, so suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean?
This one would probably be B, right?
I think so, yeah.
Okay, that's kind of how it's been worded.
Which seems
throughout
kind of
the-
different from the homework or the videos that we would watch, because he would always say we are 95% confident.
Yeah.
Oh, wait, no, never mind. Never mind. I take that whole sentence back.
Okay. You're good. Don't worry.
All right. So number 12, what is the mean of the distribution of the sample proportion?
Okay. So I don't remember what to do on this, to tell you the truth.
What was that?
But it's been a while since I've done these ones.
Are you still there?
Yeah, can you hear me?
Man, I'm having at least phone sound troubles on my side on the phone too.
Sorry.
Maybe if I try speakerphone.
Okay.
Okay.
Can you hear me?
Yeah, I can. What was it that you had said for this one?
Oh, I was just saying that it's been a little while since I've done, worked with the mean of the distribution of the sample proportions.
Yeah, it is kind of a killer for me. But for this, I think it's the same as P, which is 0.30.
Oh, okay.
Yeah.
Okay. So it just ended up being that same 30%.
Yep. Mm-hmm.
Okay. Okay, and the standard deviation of the distribution of the sample proportions?
Let me look it up. So in the review, it had multiple choice. I didn't write out the number. Let's see. Okay, so I don't think I... Wait a second. This seems to be out of order. Did we skip a few questions?
Seems like in this one, I did read over the review. It does seem like this one had more questions maybe about hypothesis test. Is that?
Interesting. Okay. Well, these next two, I actually didn't know how to, or I couldn't figure it out properly.
Okay, that's totally fine. Maybe, so the standard deviation of distribution of sample proportions. I might go on a little search right now to try and figure that one out.
Say that again?
I might just open our note here to see.
Okay. Sounds good. I'll look through mine too.
Alrighty. I'm kind of nervous for the final in
Same.
this class. There's gonna be a lot.
Yeah. Yeah. Huh. So the formula I did was the square root of p times 1 minus p divided by n. And it gives me an answer that's... Oh, it does give me an answer, actually.
Oh, awesome. Sorry about that. Sorry for the noise.
Oh, I don't even notice it really.
So, where did you find that formula? Was it just in our old notes? Or?
Yeah, it was in some notes that I took. It's under the inference for one proportion. Wait, no, sorry. Portion sampling distribution of a sample portion chapter.
Okay.
I think it's the first one for this chapter, actually.
Okay. See if I can find it.
Okay.
So would that be like 15, less than 15 or something?
Let's see if I can find it here.
Okay, sorry.
Oh, no, you're fine. Okay, so it is less than 16.
16, okay.
And then the formula I found was in 3.2.2.
3.232?
3.2.2. That's where it is in the
Okay,
section.
in the home, yeah.
But the answer I got was 0.046.
Okay, thank you. So, let me see if I can find it here.
Yeah, no problem.
Okay, yeah, so there it is. Okay. So, P times 1 minus P. Oops. Okay. So, did you say 0.01?
For the answer,
Yeah.
I got 0.046.
Okay, that's great.
And it's a multiple choice in the review, and that is option B.
Oh. Okay, so in the review, that was option D, is that what you said?
Yeah. But I think it's a write-in the quiz there.
Okay. Alright, thank you.
Yeah, no problem.
Okay, so 14, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
Okay. So I think to get this, I'm not entirely certain, but I think for this one that we just do the same formula we just did for the standard deviation, except atop or above it, we do p hat minus p.
So p hat minus p divided by the standard deviation
Yeah.
formula? Okay, that sounds familiar.
Yeah.
Okay. Well, I'm gonna see if I can crank that out.
Okay. Or at least this gives us the z-score.
The z-score?
Maybe we have to plug that in. I don't know.
Okay. Okay, so to find p hat, would we just use that 0.25, or would we? So we have a sample of 100 adults.
So for this, I just use the 0.25.
Yeah, that's what I was thinking for the p hat.
Yeah, because it doesn't give us. I don't think. Oh well, I guess you could. Yeah, no, actually, you couldn't figure out the p hat with the information given,
Okay.
but it just tells us right there because p hat is the sample proportion.
Okay.
Yeah.
Awesome. Okay.
So for that, when I plugged it into the applet, I got 0.862.
0.86. Okay.
0.862.
862. Okay. So from there, you just got the z-score, and then plugged the z-score into the applet.
Mm-hmm. And since it's asking for less than, I shade it to the left.
Okay.
And there's at least a good sign. It's one of the multiple choice answers. So it's either
Yeah, that's
true
awesome.
or forget it.
Okay. Perfect. Do you mind if I just finish that really quickly? See
Not
if I
at
get
all.
the same answer? Okay,
To get in that practice for the test.
that's right.
I'm sure it's the best thing
Okay, for some reason, I'm not taking out an answer there, giving me like an error. So I'll work on that one
Okay.
later
Sounds good.
so we can keep going here.
All right. And then we are on 14, correct? Oh, wait, no. 15.
15, yeah.
Okay, what is the margin of error?
Our favorite.
Yeah. Trying to figure out where this is in the review now. Oh, I see. So the next 3 questions are captured in just one question in the review.
Okay.
But for the lower bound, it gives me the lower and upper bounds in the answer here. For it, I got E, which is the lower bound is negative 0.003. And the upper bound of 0.029.
Okay. Awesome. Thank you.
Yeah.
Okay. So I'm trying to remember our last few lessons. We were getting the margin of error like right every time.
Mm-hmm.
But I mean that was working with proportions.
Right.
Same formula.
What I'm gonna try to do is, I think I did it this way before, is just add up the 2 and then find what's in the direct middle and see if that gets me an answer.
Okay.
Because it should be plus or minus the same number. Okay. Oh wait, no, dang it. Is that right? Okay, I'm just gonna have to figure it out the normal way, I think.
Okay. So, were you saying that like you could add the two and then divide it by two to
That's
get
what
the middle?
that's what we did for the last review. But I don't. It's not exactly working out for me this time. I don't know what I did.
Did you get 0.018 as an answer?
I didn't, but that very well could be an answer. Yeah,
Maybe.
let me give that a shot.
Alrighty. Okay, so the formal hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different from the proportion of control group subjects who do. Use a level of significance of 0.05. What are the appropriate null and alternative hypotheses? So, would it be A? That's kind of what I'm thinking.
Here.
So we're on question 18 there.
I think you are right. It doesn't match up with the review, but
Okay.
I got the same answer, just in a different letter in the review.
Okay. Alrighty.
Okay. So the test statistic. For this, I got. Wait a second. I think I got 1.923.
1.923.
Yeah. I don't know if you want to work that one out or what, because I'm unsure of that.
Sure. I'll have to go find the formula really quickly.
Okay. If you wanted, so you don't have to spend too much time away from your family, you could just put that in, and then you could work it out later if you want. I'm sure you'd want to spend time with them.
All right. Thank you, Thomas.
Yeah, no problem.
Alrighty, so the p-value.
The one I got was 0.072.
Alrighty.
Okay.
So, so we're probably failing. Right? Failing.
Yeah.
We're not failing.
Right. Let me.
My mom heard me say that, and she thought we were failing the class.
No. So the alpha was 0.05. We got 0.072, possibly. In which case, we failed to reject the null, I believe.
Okay. So D. Probably.
Yes. Yeah.
Okay.
Okay, and this is a section that I skipped. It's the chi-squared section that you have to do by hand. And I don't know how to do that. Did you like YouTube it or something like that?
The chi-squared. I just watched the videos, and he mentions it for like 2 seconds.
I'll have to watch the video again.
but I can. I have all my notes here in my planner, so I can do my best to help you understand it.
Okay. As long as it doesn't take too much time from you, I don't want to keep you or anything.
Oh, it's totally fine.
Okay.
So chi-squared. Okay. Just 1 second. Yeah. Okay. So with the test statistic, it is kind of a long process, but so I don't know how to get the p-value, but I do know how to get the test statistic.
Okay.
Okay. So here, so you take the row total and you times it by the column total, and then you multiply that by the table total for each one. So for the here, like for the 97, it would be actually it doesn't have the totals there, but I guess you just add them up to get the totals. Add up the rows and then add up the columns.
Okay.
And
I'll go ahead and do that.
yeah, I'll do that too. You ready there?
Yeah, I think so. Have you finished as well?
I just have a few more.
Oh, okay.
67, sorry about that.
No, you're fine.
Okay. Did you get, for your row totals, did you get 694, 688, and 782?
The last one I got a different one. I'm not exactly sure what to do for that though, but I did get the other two.
Okay. The last one, what did you get?
1,382.
Okay. I think that's right. I think I just added the other two totals together.
Oh, okay. And then for the bottom one, did you get 228, 344, 410, and 400?
Yeah.
Okay. And then for that bottom corner one that we had a different answer on, do you just add all of it together?
Yeah, but I think everything's added.
Okay. Did I do that? And what was the answer you got again?
688? No, I don't remember.
Okay. So I'm just going to add up all the totals again.
Okay. Okay. Thank you.
Oh, wow. Okay, I got a different answer now.
Okay.
And I'm assuming I think I'm doing this right, but I got 2,764.
It's probably right. You just added all the totals together.
Yeah, I added 228, 344, 410, 400, 694, and 688.
Okay. Yeah, I think that sounds right.
Okay. And then again, that was 2,764.
64. Okay. Thank you.
Yeah.
Okay, yeah, so the formula here, yeah, it's just the row total you times it by the column total, and then you divide it by the table total. And so you do that for each one. So for 97, it would be 694 times 228 divided by 228 again.
228 again.
Right? Or no, the table total, sorry.
Oh,
It'd be 2,764.
yikes. That's like quite a tedious process there.
Yeah, so you do that for each one, and that gives you the count for each number.
Mm-hmm.
And so from there, you have another formula. You take the observed count, you subtract expected count. So observed count minus the expected count squared divided by the expected count. So, and
then what is the expected count? I mean, sorry, the observed count.
So in the first example, the observed count would be the 97, and then the expected count is just what you get out of that first equation.
And then
so you do that for each one, and then you just sum them up. You add them together.
Holy smokes. Okay, that might be one we could do individually if you want.
Okay. Either way. Yeah, but I mean, that's what I got out of the videos, and I've been doing that, and I've been getting the right answer. So.
Yeah, it sounds right. I just would have never. I guess I wasn't paying attention to the video. I don't know, but nice going. I appreciate it. Yeah.
Yeah, no problem. Do you have the two formulas though?
Yes.
Okay.
Mm-hmm.
Okay.
Got them.
Sweet. Yeah, and then, like I said, I have no idea what to do on the p-value because it's not mentioned anywhere.
Let's see. If I have anything in my notes about it, I doubt it, but.
Okay.
I wonder if the value that we get after the end of all of that is our z-score or whatever the test statistic that we plug into the applet.
Yeah, you're right. That's right. Yeah, actually, it all makes sense now.
Yeah, oh, hey, no problem.
I tried to figure that out. There's got to be like a formula or something. Yep.
A really, really long one.
Yeah. Yep. Okay. All right. Perfect. So 24. Okay. We reject. Okay. I guess we have to figure that out.
Yeah, and 25 as well.
Okay.
Alrighty. Pretty sure I answered the rest of these. We'll see.
Okay. Alrighty, well, so the lower bound on this one.
Okay, so this, the lower bound I got was 0.190.
Okay. Did you, on these ones, were we given like SPSS document to use, or was it just all like, by hand?
Yeah, for this particular set, it was by hand, but there are two examples later on that use SPSS.
Okay.
Not that I am even sure I used that right, but it's there.
I'm sure you're good.
Okay.
Okay. So what did you get on that one? I'm gonna go through and I'll do these.
Yeah.
I'll just work on them later too.
So I got lower bound 0.190. Upper bound I got 0.310.
Okay. Okay.
Sample size. I got, all right. I got 16
16 for the
for number
sample
20.
size?
Yeah.
Okay. All right. Okay, suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05.
Okay, so we're looking for greater than for the second half, I believe.
Yeah, that would make sense.
Does that look like
So-
the second to last one to you?
Yeah, that's
Okay,
coming to my mind.
perfect. And what
Okay, what-
requirements? Oh, sorry.
After you.
What requirements must be met to ensure that p-hat is normally distributed?
Okay, so would that be A?
Yeah.
Okay.
In the review, it asks it kind of strange. It says, how many measurements must you have in order to assure that p-hat is normally distributed? And it gives the same
That is
options.
interesting.
It's really weird.
Well, I'm glad it was phrased differently in the quiz.
Me too. And for the test statistics, is that the next question?
Yeah.
I got 1.768.
Okay. All right.
And then the p-value that corresponded with that was p or 0.039.
And so that one you throw it in the applet and then shade to the right. It's greater than right.
Yeah. Mm-hmm.
Okay.
Nailed it.
Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? Probably yes, right? Okay.
Yep. Yeah, I think that's right. 'Cause we reject the no. Perfect. And now these last ones are with SPSS.
Okay.
Now, I did get answers, but I was really not confident in the particular tests I used.
Okay.
Because I didn't know.
Okay, well,
What was that?
that's fine. Maybe we can go with your answers. I'm gonna work through, like like I said, I'll probably work on these later just to
hmm
make sure I got it.
Okay.
And if I get a different answer, I can shoot your text. Or
Sweet. Sounds good. So then I'll just give you what I have for this then.
okay.
For the lower bound, yeah, this one run. I got 0.280.
Okay.
And then the upper bound was 0.300.
On these ones, could you use the Excel sheet?
You probably could.
Okay.
Trying to think if you can or not. I don't remember. You might be able to. I just used SPSS.
Okay.
And then the degrees of freedom I had was 28.
Okay.
And the test statistic was it was actually 0.000.
Okay.
Oh wait,
On
sorry,
those ones-
that was the p-value of 0.000.
Okay.
What were you about to ask?
So I don't remember on the if the p-value ends up being 0.000, do we do like 0.000 for 6 zeros and then put a 2.5 or something? I don't remember.
I don't remember either.
Okay.
And all that it said in SPSS was 0.000.
Okay.
So that's definitely one I'll have to double check.
Yeah. I can look at that stuff.
Yeah. No. Gotta find which one corresponds with where we are right now.
Okay, so the test statistic for that one. So you said the p-value is 0.00, right?
Right.
Okay, so the test statistic for that.
Trying to figure out where that is.
Okay. I'm gonna try and figure it out.
Oh, I know what I did. I didn't even look at the test statistic. In the question it says calculate the degrees of freedom and the test statistic. I didn't even read the test statistic part, so I didn't look at that when I pulled it up.
Oh, that's totally fine. Made me on there, Thomas.
Yeah, I apologize.
It's all good. Let's get, it's hard to remember which formulas to use with which ones.
Mm-hmm.
It's hard for me.
Yeah, me as well. I don't even remember what I did for that one.
That's all right. Maybe we should
just
skip and go on to the next one.
maybe.
Okay, sounds good. So we're on 39 now?
39, yeah.
Okay. So based on the results of this test, what would you conclude is a level of significance of 0.05? So with the answers that we have right now, it was lower than 0.05, so I believe it would be A, right?
Yeah, that's what I was thinking.
Okay.
Different.
And then now is another SPSS file, AM and PM height differences.
Okay.
Okay.
So does that just measure your height in the morning and at night?
Exactly, yeah.
It's an interesting study.
Yeah.
Are you taller?
Yeah, I think you're taller in the mornings. Did it conclude that you're taller in the mornings? Is that,
Let me see.
I guess you see.
Yep. Yeah. That's what we ended up saying is that you are taller in the morning.
Oh, cool. Okay.
So we were on 40 on this, which
Yeah.
is 30. Oh gosh, 34 here. Okay, so the lower bound I have is 8.728.
Okay.
And the upper bound was 10.455.
Okay.
And I did the same thing for the test statistic. I didn't look at that. Oh wait, actually I still have it pulled up here. Test statistic. I have 22.446.
Awesome.
I love that.
Nice that it was still up there.
And the degrees of freedom was 40. P-value, another reason why I'm down in this is I had 0.000 again.
Yeah, that's okay.
And then the last question is, what do we conclude?
Yes,
Because we rejected the null, so C.
Yeah, that's what I was thinking as well.
Okay.
Cool. Well, I think that about does it then.
Yeah.
Yes. On those ones that we mixed, I can go. I'll work on them,
and
and I can shoot you a text with
Okay. So,
what I figure out.
yeah, I'll give him a shot too, so I can get some practice in.
Okay.
All right.
All right.
Perfect. Well, thank you very much.
Yeah. Thank you for all your help, Thomas. All your help.
No problem. It's Thanksgiving.
Thank you so much.
You enjoy your family.
Hey, let's have a good Thanksgiving.
Well, see ya.
Okay, talk to you later. Bye.